Okay.
So, hello and welcome to this very special panel dedicated to the IMS network resilience during and aftermath the pandemic related to COVID-19. My name is Steffi Stefanova, and with Tom Hoffman, we are delighted to be hosts again on this panel. I say again because yesterday we hosted two special events on it. This morning we had another oral presentation. So we just could not cope without having those special sessions dedicated to the COVID-19 pandemic and how it reflected on the operation maintenance of the IMS network. So we'll continue this afternoon for 1 hour with our special guests as panelists. I'll present them in a moment. It will be a continuation from this morning oral session. Two of the panelists, Dave McCormack and Catherine, presented this morning. Also Tom Hoffman over there, presentation. So the panel will follow up the themes, the subjects discussed this morning. So you see, all those events that were dedicated to the COVID-19 pandemic and how it reflected on the operation maintenance of the networks. We had the presentations of the station operators, and we saw how this pandemic shaped their daily work, how they had to change their normal daily routines to adapt to it. And everybody was affected. Let's see if we can have the IMS network limited, paralyzed, broken by the pandemic, or in contrast, we can have it getting stronger and resilient after that. So to discuss those special topics, to see how we can grow in logistics, in operation, in maintenance of the network, we have our panelists here. I'm going to introduce them. So first of all, we have, it will be in alphabetic order, I'll do it. David Hardman from Australia. Hello, David. David is Assistant Director of the Radiation Monitoring Networks at the Australian Radiation Protection and Nuclear Safety Agency, ARPANSA. And they are station operator of 9 radionuclide stations as well as 2 noble gas stations in Australia. In addition to that, David is known as task leader in Working Group B on the Operation and Maintenance Manual. So welcome, David. Then we have Dave McCormack. Hello, David. We saw you 1 hour ago in the presentation and oral presentation. Dave McCormack is a managing director at Natural Resources of Canada. He's also manager of the Canadian segment of the IMS network, which includes 11 seismic, infrasound, and hydroacoustic stations. And I took note on the 180 stations of the Canadian National Seismic Network that are operated by this entity. So quite a important network operated by Natural Resources of Canada. Welcome, David. Then we have from Chile, Paula Garcia. Hello, Paula. Paula is working for the Chilean Nuclear Energy Commission, SECHEN, and she's station manager for 7 Chilean CTBTO stations and also of the National Data Center of Chile. Paula is part of the team of task leaders for Working Group B and also is part of the 3rd training cycle, so surrogate inspector for OSI. Welcome, Paula. And Catherine, good morning, Catherine. Good morning. We appreciate to be with us so early morning. Catherine is joining us from Colorado. She's Senior Program Manager at the IRIS, which stands for the Incorporated Institutions for Seismology. And since 2015, Catherine is the Program Manager for the Global Seismographic Network, GSN. We saw that in the presentation with a large number of stations worldwide, and among them 50 stations which are part of the IMS Auxiliary Seismic Network. So welcome to all of you, and we can start our discussion with some questions. Tom? Sorry, Alexei. Sorry, because I went on the alphabetical order of countries. Of course, Alexei and Shenko joining us from here, from that same building, from the agency, from the International Atomic Energy Agency. And Alexei is Director of the Scientific and Technological Services Division of the Safeguards Department of the agency. Welcome, Alexei. Okay, so we can start with the discussion, I think.
Thanks, Steffi. Great introduction. Welcome to everybody on the panel. And I will start with the first question to David Hartman. What were the global impact and the consequences that COVID-19 pandemic had on the operation and sustainment of the IMS monitoring network? Could you please elaborate a bit on this?
Yes, hello Steffi and Thomas, and thank you for that great introduction. So, I guess my question is that we're defining the problem that we've all experienced over the past year or so, and I guess we've as an agency have noticed a few key areas that have definitely affected us as part of the pandemic. So from our point of view, there's really been 4 major consequences on the IMS network from our perspective. So those 4 areas really have been travel, site visits, shipping being number 2, relationships, and also the final one being the extra workload that's been required on the station operators. And I'll go through those in a little bit more detail throughout my answer to that question. But I guess we've all had a different experience of how COVID's affected us, and from our point of view, Australia has had really relatively low cases of COVID-19. However, it's been managed through significant lockdowns. Each state and territory has had different ways of handling the situation, and it's made life quite uncertain for living, but also for continuing on with our work that we're trying to undertake. So our challenges might be slightly different to the rest of the globe due to our low numbers. However, I guess we've still managed. All of us have managed to continue our work in some fashion. But Australia has had a really low risk model where we, lock down very quickly if there's been even as low as 3 or 4 cases. Certain areas of Australia have locked down, and that's made travel in particular and site visits quite difficult to undertake. And even, our country in particular is quite isolated, which in some ways, as far as COVID has been great, but it's also mean that it's been impossible to actually even leave the country for work-related processes. We've had site restrictions. We've had permits even to move within our states. And we've even had entry rules changing mid-flight. We've had staff up in the air and they land and all of a sudden they've got to quarantine for 2 weeks. So there's been some quite significant challenges. So I guess really to look at our network, I gives us a bit of, I guess, appreciation for what it is that we're trying to undertake. So we have 9 stations, as Steffi mentioned before, 9 radionuclide stations, that is. But they cover a range. I mean, from the further stations, there's 12,000 kilometres between our 2 most furthest away stations, and time zones ranging across 8.5 hours. So that in itself makes things and remotely managing these stations quite difficult. Some of these stations are tropical, some of them are in the Antarctic, and only a few are really in the major cities. So that really takes me along to our first consequence, our first challenge really, which has been travel. So as I mentioned before, state lockdowns and flight cancellations have been commonplace. And we've had really not one visit that has not had to have been changed or altered in some way. So this overall has led to maintenance delays, particularly across 2020. And since then, we have managed to perform and catch up with a lot of maintenance, but it's only been across our mainland stations. So we still have 2 in the Pacific that we have managed to not managed to be able to get to, and 2 in the Antarctic. So for some of our trips, we've had to factor in quarantining for 2 weeks, at each state's request. And this has led to longer trips and time away from the office. The second area that really has had significant challenges has been in shipping. And although within Australia, shipping has been quite good, getting things to the Pacific Island stations has been quite difficult because, and if we look at Kiribati as an example, so that's KIP 39, they've not had one COVID case, which is amazing, and they really couldn't cope with having a COVID case because it would be catastrophic to their community. But that has meant that we're pretty much locked out. They've stopped all flights. They've stopped a lot of shipping, and it has meant a lot of delays in even getting things to the station, consumables, tools, a whole lot of items. So the third area really is relationships, and working from home has provided challenges. There's been some great new tools that have been available to us, but there's certain aspects that are missing. The ability to meet and bounce ideas off each other, and hands-on work. And as we're an operational sort of group, that has caused quite a challenge going forward. And an example, and again this relates to Kiribati, is that we were lucky enough to take on Fiji and Kiribati in late 2019. So we're now the operations and maintenance team looking after those 2 stations. However, we only had a handover visit essentially, and then we were tasked with looking after on an ongoing basis these 2 stations. So we had a lot of big plans, for these stations, and they all had to be put on hold. So although that's okay, essentially we're looking after a station where we weren't able to put and create the sort of environment that we wanted to I guess look at implementing at these particular stations. However, we were lucky that the local operators, even in that short period of time, we were able to build up a really good relationship with. And those guys have been really the key to keeping these stations going. They they themselves are not getting, deliveries or access to shipping items in, but they are amazing at being able to, with very few resources, keep those stations operating. So the local operators, the relationships with the local operators really, has been difficult and challenging during this time. But there is also, the ability to work with these guys. And I guess finally, the last point is the extra workload. Procedures and a lot of tasks have to be written or modified to be able to put out to the local operator. They might have been procedures that were meant for people that have been to a certain amount of training, or I guess have experienced operators, station operators, working with these particular tasks. So we had to modify a lot of procedures and make just smaller, how-to guides and things like that. We had to look at new communication solutions as well. So we had to look at how we could communicate with these guys a little bit better, and what programs, like, some of these, in particular, Kiribati doesn't have a very good mobile network. So we had to look at the best way to communicate with these guys. We had other stations that had changes that were scheduled anyway, as far as employing new local operators. And this is particular at COCUS AUP08, where we had to train and employ new local operators remotely. So, there's been quite a load on extra workload on the station operators to actually keep things running. We've been lucky enough here in Melbourne to have an amazing travel officer that, despite travel changing on a daily basis, will support us in reissuing tickets and making sure that we actually get there to do our work. So in conclusion, really, the four areas that we can see where the pandemic has affected us, again, is travel, is shipping, is relationships, and it's the extra workload that's required. So, although this really is the problem, we've come up with solutions for some of these problems, and hopefully later on in the discussion we can get to it. We can get to some of those solutions that we came up with. So that's my answer to the first question. Thank you.
Thank you so much, David. This was a very good and precise summary of your situation, which easily can also be expanded, I think, to other parts of the world. It sounds like you're facing, or you have faced, similar issues. So I would then move on to the next question. Steffi, you wanna go for that one?
Yes, and thank you also from my side, David, for this summary, because the problems that you outlined, for sure, they have been faced by all station operators of networks. And I would like to ask Paola, who is operating stations in very similar conditions, very similar geographic and climatic conditions. Paola, how the US station operators, the China station operator, managed to mitigate those problems so that you're sure the continuous data stream from your stations to Vienna, and I know it was the case. So what you did, how you managed to do that?
Thank you, Steffi. First of all, thank you very much for inviting me, and thank you for the introduction. First, I will give you a context of my country. Chile is a country of about 18 million inhabitants. And our institution, the Chilean Nuclear Energy Commission, is part of the Chilean government, from which we have a strict plan concerning this health emergency. And we have to see that we had the peak this year with more than 9,000 cases per day in April. And thanks to the vaccination process and the sanitary restrictions, yesterday we had less than 5,000 cases. So that is very good, and it's very good for our operation too. And our institution, the 10, hosts our NDC and is in charge of the 7 Chilean stations. All these stations are distributed in 3 locations: Easter Island, Robinson Crusoe Island, and in Punta Arenas, which is in the very south of Chile. That is to say, in addition to the more than the 300 workers that the 10 has, the personnel related to the treaty in our country are 10 operators, including myself, and all of us are already vaccinated. Fortunately, each of these locations has personnel who are permanently available. For example, we do not face the problem of not being able to travel to the station for operation and maintenance because the operators live in those places. Since the beginning of the pandemic, our institution has been very concerned in ensuring that the stations continue to operate and their operators have the same resources that they always have. However, the logistical aspect, as David said, has been very complicated since at the beginning the shipment to the islands was restricted and maintenance trips are still not possible in Easter Island, for example. In the case of Robinson Crusoe Island, something similar happened with equipment because we can receive equipment, but it cannot be installed since the personnel are required from the mainland or from Vienna or other countries. However, on both islands, some maintenance has been carried out by local personnel, what is good for those occasions too. In Punta Arenas, from a logistical point of view, despite being within the mainland, since the end of March 2020, there have been problems with the transportation because many truckers didn't want to make deliveries in that location because they were afraid of being infected because there are too many cases in that area. And there were also roadblocks in the Argentinian sector because Argentina was under a strict quarantine and didn't want the truckers to circulate along its route. And the air transportation was also affected because of the reduction of flights. And all the sanitary cordons. However, since access to the region is not restricted, some maintenance can be carried out without any problem. In the case of our national data center, the operation has been completely remote, using NTC in a boat and meetings online, and only the antenna maintenance was carried out in the field, there in Santiago, where the NTC is located. In general terms, the acquisition and management of shipments was the factor that was most affected during the pandemic, along with access to a specialized personnel to perform a specific maintenance. Fortunately, our institution has a procurement department and the external support of a customs agency, which means that all the shipments can be performed without any problem. In terms of health of our personnel, each of our locations has faced different situations. For example, Easter Island is completely isolated. Nobody enters, nobody leaves, which has been a benefit for the community since they don't have any case. But the problem is for our institution because it's very difficult for us to send shipments, or it's impossible, it's not allowed for us now to send people there. And different situations in Robinson Crusoe because we need a 15-day quarantine. Having also personnel in the mainland is very important because we can be in contact with the local operators all the time. The financial management of the project has not been affected, only the costs that have increased a lot. Our personnel on the islands have not been affected by COVID-19. However, our personnel in Punta Arenas, composed of 3 workers, and the 3 of them were infected and 2 of them very critically. Fortunately, at the moment, they are recovered. In conclusion, our institution has made every effort to continue with the normal operation of the station. Our normal way of functioning allow us to face this sanitary emergency in the best possible way without significant inconvenience. Thank you very much.
Thank you very much, Paula. We really appreciate the efforts of CTN for the operation maintenance for those remote stations, which is not obvious, on Fernandez and Easter Island. So it's really appreciated. Thank you very much for sharing with us your experience.
Welcome.
I would like to address the next question to Alexei Anichenko from the IAEA. And my question would be how the situation was mitigated by other organizations and networks. You have the floor.
Good afternoon, good morning, everybody. I'm really delighted to be part of that panel, and my remarks will not be differ much from what you have already heard from the station operator, from David. It's the things what happened with the agency and measures what agency implemented is about the same. And the impact of COVID-19 pandemic, as we know, has been far-reaching. Governments implemented strict measures related to health and safety for the containment of coronavirus, such as physical distances, restricting travel and free movement of people, grounding flights and restricting other means of travel and closing borders. These measures have significant impact on agency implementation of safeguards, and in particular on its ability to conduct a number of its planned in-field verification activities. This requires the agency to take a number of measures to overcome new challenges or mitigate their impact. To achieve its safeguards ability for a state, the agency needs to implement safeguards activities for the states in accordance with its safeguards agreement. Each year, agency prepares annual implementation plan for each country, and during pandemic time, these plans were adjusted. As many of big organizations, the agency is committed to the resilience of its operations even during this kind of disruptive events. The agency has created, before the pandemic, business continuity and disaster recovery measures and put them in place. But the situation was different from what was planned, and those continuity and disaster recovery measures would require to be updated in order to mitigate the effects of pandemic on the safeguards activities. The global travel restriction and health safety measures introduced a lot of challenges. Access to consistent and up-to-date information about frequently changing restrictions and measures poses a particular challenge when planning in-field verification activities. In this case, close collaboration with states, including particularly the Republic of Austria as a host state, remains essential to overcome these operational obstacles. For in-field verification activities, travel in-country restrictions are making it harder for the agency to reach a large number of nuclear facilities, sites, and other locations, and are also having an impact on the timely shipment of equipment in support of field activities. In order to accommodate such restrictions, intensive coordination efforts were required at the agency headquarters. Agency inspectors and technical staff were making extraordinary and still continue making extraordinary efforts to fulfill their duties. For example, by isolating for up to 14 days in their destination state, driving long distances and crossing various national borders to conduct verification activities instead of flying, embarking on mission without having any confirmed date or means of returning back to Vienna, and having the length of missions extended significantly. The cost of transportation, in particular flying to a number of destinations to conduct in-field verification activities, has increased significantly and went beyond the budgetary travel appropriations. For many states, mandatory quarantine period adding additional significant length of verification missions. In addition, travel logistics and quarantine requirements frequently prevent agency inspectors from combining travels to carry out verification activities in different states. Consequently, performing a number of activities has required more and longer trips by agency inspector and technical staff, which was adding the cost. In response to the unavailability of many commercial flights, the agency has, for the first time in its history, concluded contracts for provision of aircraft charter services. So the agency had private jets to carry out inspectors. This arrangement has already been used successfully to transport more than 200 agency inspectors and technical staff to conduct inspections in 10 states. In light of COVID-related restrictions, as I already mentioned, the agency has adjusted their annual implementation plans to focus inspections efforts on achieving the most time-critical and time-bound safeguards objectives. And where appropriate, has rescheduled inspections, rescheduled design information verification, and complementary access activities. Where necessary and feasible, the agency also implemented compensatory measurements, such as increased reliance on remote data transmission, the additional use of remote monitoring to maintain continuity of knowledge and to minimize the future impacts on any delayed activities. All safeguards equipment requests from within the Department of Safeguards has been processed, including the provision of verification equipment and personal protective equipment to all agency inspector and technical staff for the duty travel. The agency investment in remote monitoring system over the past 2 decades has proven invaluable during the pandemic, with more than 1,600 data streams continuing to deliver safeguards equipment data from facility in 31 states to agency headquarters. As a consequence of the pandemic, many planned maintenance activities has been postponed. The agency implement very broad and very well thought way how equipment is installed in nuclear facility, and failing of one piece of equipment does not lead to lose of the information, and this was a significant. And this approach was proven very valuable during all this time. In 2020, the agency nevertheless conducted over 20 trips related to inspection supports and over 30 trips related to maintenance, installation, or support for the safeguards equipment. While a number of member states were willing to provide financial assistance to the agency to purchase personal protective equipment, the global shortage of that PPEs was a critical issue, and the agency conducted its own contract purchase agreement to buy and additional PPEs, and particularly it was a problem with FFP2 and FFP3 types of masks. In addition, the agency organized, together with the medical service, organized PCR tests for the inspectors which are going out in the field and coming back. It was over 1,600 PCR tests were taken by the medical service. The numbers proven that that all the measurements what we done to protect our staff was well placed. There was only 6 cases when the staff contract the virus while conducting in-field certification activities, while that all inspectors spent 15,000 days in the field. It's very low number. And one of those who tested positive, for example, for COVID-19 while being on a duty travel in the States was repatriated successfully to Vienna. We are using the charter flight, what I was already mentioned. The staff member received excellent support from the state authorities upon arrival to Austria. Training activities was continued, and a lot of those training activities were done remotely. Member states' mission in Vienna and their national authority continue to have a very important role in ensuring and facilitating the agency continued access to the nuclear facilities. So working with the states was crucial point to make sure that everything goes smoothly. And in conclusion, that despite the difficult situation, the agency would not interrupt its verification activities and has continued to implement safeguards effectively during the COVID-19 pandemics. When necessary, it has implemented a series of remedial and mitigating measurements, but it's of course significant impact, not effectiveness, but efficiency. So the much more resources were spent. In short, I echo what David has said, that we experienced almost the same challenges, and I completely agree with all these 4 items what David has mentioned. With that, I conclude my remarks. Thank you. Did you hear me? Okay.
Yes. Now it's okay.
Okay. Thank you so much, Alexei. This was a great summary of a different organization, but we can see that there are many similarities in the problems that we all face, and interesting to know how you tackled them.
It was a different experience with probably different scale of personnel to handle. But as you said, the same problems, and thank you very much for sharing with us this experience from the agency. My next question will go to Catherine. Catherine, we listened to your presentation this morning that was also showing the same range of problems, and we need to show that we know how to tackle those problems, that we know how to do better to get out of this critical situation. Can you summarize for us, like in a global scale, what are the lessons learned for all this situation? You have your own experience, you have the experience that was shared. How we can summarize this? What we learned, how we get out from it?
Yes, I'll be happy to speak to that. Thank you for the opportunity to participate in this panel discussion. And as already mentioned, I'll be sharing lessons that were learned by the GSN during the events of the last year and a half. Our experience was very similar to what we've already heard from the other panelists. And at the end, I'll offer maybe a suggestion of ways that we could move forward and deal with these kind of situations in the future. So as we all know, the global pandemic was one of those rare events that affected almost every country in the world. And it was one of the first times in recent history where travel was prohibited, not just between countries, but also within country borders. And in many countries, intercity travel restrictions were implemented, and any travel was limited to, securing life's basic necessities, dealing with emergencies, and maintaining critical infrastructure for the population. So the GSN was fortunate to be able to continue its data collection and distribution at a level that was within about a 1% data availability of the level that we had before the pandemic. However, I must say that some of the quality of the data ended up decreasing at stations, particularly where seismic sensors that require sort of complicated installation techniques failed. And this is primarily our sensors in deep boreholes. As other people have mentioned, we were able to rely on newly developed information and communication technologies to maintain contact with local personnel. And we even could do some remote troubleshooting. However, the virus dictated and continues to dictate where and when work can actually be accomplished. As large parts of the world are still not vaccinated, we still have considerable uncertainty about our ability to travel and visit stations. Currently, we can only visit stations that are in the US or US territories. So what can we learn from this? Well, as with the IMS, we've established long-term working relationships. We've conducted training and put spare equipment in place. But we realized that our current station design really relies on the ability to travel to the station for maintenance and repairs. In this case, the pandemic limited travel for our local collaborators as well. They were not able to reach the stations any better than we were. The weakest links we found were most commonly power and communications equipment, and particularly such things as cables associated with these functions. In very few cases was it the actual seismic equipment that failed. It was the small things that kept things from operating. So I would suggest that perhaps this is something we should rethink and guard against in the future. As much as possible, perhaps our stations should be built to operate truly anonymously without any human intervention required on site. Station designs might be simplified to accomplish the desired goals more effectively with less power, and be engineered to continue working under every possible scenario that could interrupt station operations, even ones that we haven't even thought of at this point. This would involve more extensive time and budget spent on standardization of equipment and testing equipment and configurations before installing at a site, so that there are very few unexpected issues. We humans have shown that this is possible. On extreme levels, we have successfully deployed seismometers on Mars, repaired equipment with robotic devices, and recently conducted multiple successful helicopter flights on a planet hundreds of millions of miles from Earth, all without any humans on site. I believe that part of that success is the result of prioritizing the idea that how do we ensure that the systems and equipment do not fail and will continue to be able to work under the most extraordinary conditions. This, of course, takes a lot of money and planning, but it is, I think, a possibility for us to think about in the future. Perhaps we can use a recent example of the successful deployment and operation of over 200 high-quality post-hole seismic stations in remote regions of Alaska and Canada as a model. These stations were designed to operate under extreme conditions and without any human intervention for at least 24 months. We accomplished this by testing a station design repeatedly ahead of time. Once a successful configuration was developed, we replicated that design everywhere, and the stations were deployed in a production mode, so everything was done the same wherever the stations were put in. This might be a model to be considered for future station modifications and designs that would allow us to have truly autonomous long-term operations. Of course, there's always room for improvement in the reliability of our stations. I think all of us worked very hard to maintain the operations during a very challenging time, and I think we're largely successful. This, however, depended very much on the importance of relationships with the local station operators who do a lot of the maintaining, monitoring, and repairing of stations. We cannot underestimate the value of their contributions, and it was their contributions that helped continue successful operation at, for us at least, pre-COVID pandemic levels. Thank you.
Thank you very much, Catherine. All those lessons learned, for sure. We're gonna review all those discussions. So we'll take notes. I believe for the audience the same. Very valuable lessons learned for experience from all of you. So our next question will be to Dave McCormick. Go ahead.
Yes, David, I saw your presentation this morning, and thank you very much. Excellent presentation. And I just wanted to start before asking you the question to congratulate, and it also follows in what Catherine was just saying as an example, that you have those remote stations. Obviously, you have these Arctic stations, and for me, listening to your talk, it really sounded you were well prepared because of that, probably because you're used to the situation. You have to deal with something that you can't access so easily, and so I congratulate for the good results and the excellent data availability that you've shown. So the question I would like to ask is how to prepare for future network operation challenges by introducing precautionary measures at this time. You're muted.
Somebody had to do this during the panel. It was inevitable it was going to be me. So first of all, thank you, Thomas and Steffi, for putting this together. I think it's been very interesting. I must admit, I'm particularly interested listening to Alexi from a different perspective and learning how another organization has done this. I think there's some really interesting lessons that we can learn there. So, but I appreciate hearing everybody's experience. And I think when all of this is over, we really are going to have to make sure that we make a concerted effort to capture all of these lessons, because this is something I think that is going to be referred to at least for a generation to come in terms of the impact that it has on how we do our operations. And those of us that are living through it at the moment, it's easy to imagine that we're never going to forget any of this, but I suspect in a couple of years, it'll all seem a little bit like a bad dream. And many of the things that we've learned now, we're going to start to forget rather quickly. So my first lesson, I think, and we've tried to show a little bit of an effort here, as I referred in my talk to a paper that we've recently written. on some of the at least initial lessons from COVID is document. Let's write this stuff down and let's get it out in the literature so that engineers and technicians and scientists in 10, 20 years time will have a reliable source to go back and mine for some of this stuff. But you ask a very interesting question, and it is a question we've really started to think fairly hard about. I think the bottom line for us has been that there's a fundamental tension, I think, between two sets of different pressures. For the seismological community, I think there's a pressure to get as many sensors out into the world and collect as much data as possible. And as you all know, no one's ever met a seismologist that said, no, thank you, I've got enough seismometers in the field, I don't need any more. At the same time, the business of running permanent reference networks requires, I think sometimes, and Catherine did refer to this, a decision to be made that it's not getting as many sensors out at all costs. It's balancing that with getting networks built that are robust and reliable. And that in some cases, that means that you have to build fewer, better, and more expensive stations than you would do if it was simply a matter of optimizing your network coverage. Now, for the CTBT, you don't have that challenge so much because, of course, the scale of the network is predefined. But it still exists, I think, in the conversations around the investment, capital reinvestment, and in the operating costs of the network. So I think that's something we have to pay attention to, where that balance should be. And I think more broadly, and I've seen a lot of discussion about this more generally in the literature in the last few months, recognizing that as a society globally over the last few decades, all of our supply chains have become very, very tightly wound up. And everything is just in time, and everything is, right back to the manufacturer, supplier. And that, in a sense, that's completely opposed to the development of resilient systems. And I think we've learned a couple of times now, and we really got to start actually living the lesson, that efficient and resilient are not necessarily the same thing. I think we had a little bit of a pre-warning of this during the Fukushima earthquake when we saw the impact of the interruptions in supply chains globally from manufacturing in Japan. And I don't think we really quite learned the lesson. And I think we're really learning it again now. And I think in our own business, our own industry of running these global or large regional geophysical and monitoring networks of various sorts, I think we have to take a hard look at where the balance is between efficiency, having everything centralized, having everything in a depot, versus resilience, which I think really means looking at having spares, perhaps duplicates of stations right out at the station level. As Catherine said, making the stations as simple as possible so that they can be at least a first or even second order repaired by people who are effectively untrained, and really reserving having to send dedicated trained staff to places only for the most serious of failures. And I think that's a recognition of what we're looking at in terms of the new normal here. I think, realistically going into the future, yes, we've seen this massive investment in having great new tools that let us all collaborate remotely like we're doing right now, instead of all sitting together in Vienna and having this discussion. But the consequence of that, and we've had this already in the last Canadian federal budget, is that the money that was used to develop these new tools has been taken directly out of our travel budgets. And there's a one-to-one correspondence more or less there. So I think, we are going to have to find ways to travel less in the future. There is going to be an expectation. Of course, these types of activities will always have some travel associated with them. But I think there's going to be an increasing pressure from a fiscal perspective, and also, frankly, in terms of our contribution to environmental considerations about reducing our travel footprints. You're waving at me that I've got 2 minutes left, is that right?
Yes, that's correct.
Okay, so those are the main comments I wanted to register. I think the only other thing I'd leave you with, just as a thought, there are other areas I think we need to pay attention to where there are perhaps vulnerabilities in our networks waiting to happen. One, because I'm also not just responsible for earthquakes in Canada, but also space weather. We're looking a lot at the moment at the vulnerabilities created by our dependence on GNSS systems. And that's something I think, you guys collectively perhaps could benefit from having a good hard look at as well. I think we've developed an overdependency there, and it really is a single point of failure. And equally, taking a lesson from the space weather world, we've been through a process quite recently of mutual cross audits. This is just pre-COVID, to validate our space weather forecasting. And I think it would be a really interesting exercise when we are able to do this again, to look at a more or less formalized process for sending teams of people into different network operators and actually do audits of various kinds, mutual audits, with the proper respect and the proper recognition of the variations between different groups, but really to dig into the details of where some of these vulnerabilities might be. And I think that would be an excellent way for us to learn collectively about how to improve the systems in the future. So those are just some initial thoughts, conscious of time. Thank you.
Thank you so much, David. Was especially at the end, we got some real special input we have to think about. That's perfect. Steffi?
Thank you very much, David. I think we all wish this could continue at least for 1 hour more. We've been notified that it's all the end of that session. So thank you very much to the organizers. Thank you very much to the audience that followed that session. Thank you very much to our panel, to Alexei, to Catherine, to David, and to Paula. Thank you very much. We hope to see you around. And good continuation. Thank you very much for your own efforts in mitigating and dealing with this situation. All the best to you and goodbye.
Thank you. Goodbye.
Thank you.
Thank you.
Thank you.
Thank you. Bye.
So why did we have 5 minutes?